Welcome to Neural Monk. In this video we go deep on ChatGPT, how it was built, how it generates answers, and why it sometimes gets things wrong. By the end you will understand exactly what happens between your question and ChatGPT's reply. ChatGPT is an AI chatbot built on a large language model called GPT. The name breaks down like this: Chat is the conversational interface. GPT stands for Generative Pre-trained Transformer. And the transformer is the neural network architecture underneath. ChatGPT is built on three pillars: pre-training on raw text, fine-tuning on instructions, and alignment through human feedback. GPT uses a decoder-only transformer. Unlike the original transformer, which has both an encoder and a decoder, GPT drops the encoder entirely. It stacks 96 transformer layers, each containing masked self-attention and a feed-forward network. The key word is masked. GPT can only look at past tokens, never future ones. This makes it a perfect next word prediction machine. Before ChatGPT can talk to you, GPT is pre-trained on an enormous corpus of text. GPT-3 used over 570 gigabytes of text, common crawl web pages, books, Wikipedia, and GitHub code. The training objective is simple: given a sequence of words, predict the next one. This is repeated across trillions of tokens until the model learns the patterns of human language. ChatGPT never reads raw text. First, the text is broken into tokens using byte pair encoding. A token is roughly 3/4 of a word. The vocabulary has 50,257 tokens, each mapped to an integer ID. The sentence "How does ChatGPT work?" becomes 6 token IDs. The model processes only these numbers, never the original characters. Each token ID is converted into a dense vector, a list of 12,288 numbers for GPT-3. This is called the embedding. Similar tokens end up close together in this high-dimensional space. A positional encoding is then added to each embedding so the model knows the order of tokens. Without this, the transformer has no sense of which word came first. Inside each transformer layer, masked self-attention lets every token look at all previous tokens to build context. The word GPT in our sentence attends to how, does, and chat, but not to work which comes after it. This masking is what allows the entire training sequence to be processed in parallel, making GPT training feasible at scale. The entire pre-training is driven by one loss function: cross-entropy between the predicted next token and the actual next token. The model runs a forward pass, makes a prediction, compares it to the true next word, computes the loss, and runs backpropagation to update all 175 billion parameters. This cycle repeats trillions of times across the training dataset. After pre-training, GPT knows language, but it responds like an internet text completion engine, not a helpful assistant. Supervised fine-tuning fixes this. OpenAI used human contractors to write thousands of ideal prompt-response pairs. The model is then fine-tuned on these examples, teaching it the format, tone, and helpfulness expected in a real conversation. Reinforcement learning from human feedback is the secret ingredient that turned GPT into ChatGPT. Human raters compare multiple model outputs and rank them. These rankings train a reward model that scores response quality. PPO, proximal policy optimization, then updates GPT to maximize this reward. The result is a model that humans actually find helpful, harmless, and honest. When you send ChatGPT a message, here is exactly what happens. Your prompt is tokenized. The tokens pass through all transformer layers in a forward pass. The final layer outputs a probability distribution over 50,000 tokens. The model samples one token. This is the first word of the reply. That token is appended to the context and the whole process repeats, one token at a time, until the answer is complete. The context window is everything ChatGPT can see at once: your system prompt, the conversation history, and your latest message. GPT 3.5 supports up to 16,000 tokens. GPT-4 supports 128,000 tokens, roughly an entire novel. Anything outside the context window is completely forgotten. This is why very long conversations can lose track of earlier details. Temperature controls how ChatGPT samples from its probability distribution. At temperature 0, it always picks the most likely next token, giving deterministic, precise answers. At temperature 0.7, the ChatGPT default, it occasionally picks less likely tokens, making responses feel more natural. At higher temperatures, output becomes creative but risks becoming incoherent. Every ChatGPT conversation starts with a hidden system prompt and instruction set the user never sees. It tells GPT who it is, what rules to follow, and how to respond. For standard ChatGPT, it says something like, "You are a helpful, harmless, honest AI assistant." Custom GPTs change the system prompt to create specialized assistants, a coding helper, a customer service bot, or a creative writing partner. ChatGPT has one critical flaw: hallucination. Because GPT predicts plausible text rather than retrieving verified facts, it can confidently state things that are completely false: fabricated citations, wrong dates, invented people. It does not know what it does not know. The fix is retrieval augmented generation, RAG, where verified documents are injected into the context before GPT replies. ChatGPT Plus extends the model with powerful tools. Web search adds live internet access. The code interpreter runs Python in real time. DALL-E generates images from text. File Reader parses PDFs. These tools transform ChatGPT from a text predictor into an active agent. GPT-4 is a major upgrade. It has roughly 1 trillion parameters versus 175 billion. Its context window is 128,000 tokens versus 16,000. It accepts image inputs. Its reasoning scores at human expert level on the bar exam and medical licensing. GPT 3.5 stays faster and cheaper for simpler tasks. How you phrase a prompt dramatically affects the output. Vague prompts give vague answers. Specific prompts with context and format get precise results. Adding think step-by-step triggers chain of thought reasoning. Prompt engineering is now one of the most valuable skills in the AI era. ChatGPT has layered safety. A moderation filter screens your prompt before it reaches GPT-4. RLHF training has built-in values that cause refusals. An output filter checks the reply before you see it. Red teaming finds and patches edge cases. Despite all this, AI alignment remains an unsolved problem. Here is the complete picture. Training: raw web data pre-trains GPT on next token prediction. The base model is fine-tuned on instruction examples. RLHF aligns the output with human preferences. Then the model is deployed. Inference: your prompt is tokenized, passed through GPT-4, sampled token by token, and streamed back to you. One model handles an enormous range of tasks. It writes and edits content, generates and debugs code, summarizes documents, tutors students, and brainstorms ideas. No retraining needed. The same model does all of this simply because of how you phrase the prompt. Knowing the limits makes you a better user. The knowledge has a cutoff date. ChatGPT hallucinates facts with apparent confidence. It has no memory between sessions. Long conversations lose earlier context. Use it as a powerful tool, but never as a source of ground truth. The roadmap ahead is remarkable. GPT-5 promises stronger reasoning and fewer hallucinations. Context windows are growing towards millions of tokens. Persistent memory across conversations is rolling out. Voice and video modalities are becoming mainstream. And agentic AI models that can plan, browse, and complete multi-step tasks autonomously is already here. 8 things to remember. 1. ChatGPT is GPT-4 plus RLHF. 2. Pre-training learns from raw text. 3. SFT teaches instruction following. 4. RLHF aligns with human preferences. 5. One token at a time. 6. Context window is working memory. 7. Hallucination is real, verify facts. 8. Better prompts give better answers. And that is how ChatGPT works, from raw text to your answer, explained completely. If this video helped you, please subscribe and hit the bell so you never miss an explanation. The next video covers how GPT-4 reasons through hard problems using chain of thought. See you there.